Yeah, thank you very much, Alicia, for this warm welcome, and thank you very much for all of you who showed up. We actually didn't go to the party tonight to do our best performance today, to be able to do that. Anyway, so we're talking about biodiversity, a lot of talking about communication, and there's always a big discussion. Should we rather scare people, or should we rather give hope to people? And, we are playing a bit good cop, bad cop. I'll scare you, and then my panelists will give you hope. So to scare you, I unfortunately only have to give you the latest scientific figures on biodiversity. Imagine you would weigh all mammals that exist on this planet at this moment, and you would divide them in 3 categories: humans, livestock, and wild mammals. Then 36% of that biomass would be humans, 60% of that biomass would be livestock, mainly cattle and pigs, and only 4% would be wild mammals, from tiny shrews to blue whales. So that's the first thing I'd like to share and scare you. And the second thing is, this DLD was attended by almost 2,000 people. And imagine there would be a DLD mountain gorilla, and the organizers of Mountain Gorilla DLD would be even more successful than Steffi and her team. And they would achieve that 100% of mountain gorillas, every single mountain gorilla living on this planet, would show up for this DLD event. Then, unfortunately, half a venue or a location with half the seats would be enough, because there are only 1,000 mountain gorillas left on Earth. And what we should realize is that when we started out, or when, let's say, 100,000 years ago, humans and mountain gorillas were probably equal in numbers. So it's not that we were always abundant and they were always rare, we just changed the entire picture. And it's not only mountain gorillas. There was a recent scientific publication, and they found that there are at least 515 vertebrate species, so species that have bones, which have less than 1,000 individuals remaining. So this is really a very, very doomed situations. Yesterday, Maria told us already, every 6 seconds we lose a soccer-sized pitch of rainforest. We lose about 150 species a day. And so what we can say is that obviously natural intelligence brought us to the brink of the 6th mass extinction. The question, and now we're coming to hope, is that we hope, in a way, that artificial intelligence might help us to prevent the 6th mass extinction to happen. And of course, we all know the best is if we can mix both. So if we have natural intelligence and artificial intelligence to achieve the goal to secure the basis of our life. And this is actually what you see here on the panel, the best combination there is for the combination of of artificial and natural intelligence. So I'm very happy to have Alex and Martin here with me. We start with Alex. So the numbers I just gave you, what we see there is that there's one big challenge here. How do we get all these numbers? We don't even know how many species exist on our planet, and we very little know about what these species are doing. And I can tell you, I'm a wildlife biologist. When I did my PhD in West Africa, we captured and radio-collared antelopes. So they got a 500-gram radio collar, and then I was driving with my car and with my antenna looking for these animals. And we radio-collared antelopes, hyenas, and leopards. And for the leopards, for example, it took us hours and hours to get one single signal. Very often the leopards vanished in the close vegetation of the rainforest, or they were sleeping somewhere. They were, I don't know, we didn't know where they were. So it was a very time-consuming endeavor to get very few data points. Now, Alex, please tell us, what are you doing to make this easier for biologists like me?
Maybe I can show you.
That would be great.
How about that? The one thing I think that is really clear is that we can benefit from some of the 4 trends I think that has happened. One is exponential computation. And you look at things like the NVIDIA chip, right? The Intel 4004 transistor, when it first came out, had something like 2,300 transistors. The Intel Blackwell or NVIDIA Blackwell transistor now has 208 billion. So that gives us incredible computational power. It's an exponential, as we've heard. We have exponential connectivity due to satellites like Icarus that we'll hear about, and also Starlink that's out there. We have the opportunity, all these sensors that are in your cell phone are now in the environment, right? And so we have the ability to create an internet of ecosystem things to be able to use. And this ubiquitous sensing from local to global areas, from DNA to acoustics and machine vision, gives us new ways of actually doing conservation at scale, and exponential local analysis through something called Edge AI that's in some of our products. And what that allows us to do is really understand what's going on in the planet in ways that we've never understood before, and give leverage to conservationists. There's a $700 million a year gap in conservation funding, and this is one of the ways we can help close it. So just to kind of show you, one of our technologies is called the Sentinel. It takes a camera trap, which is a infrared, motion-activated camera, takes your picture, takes videos, and it makes it smarter. And so it plugs into every camera trap, because every camera trap has a memory card. And then through Edge AI, not in cloud, but locally, it does analysis. And the analysis allows us to do species, disease, environmental crime, behavior. And you can see examples of this. This is the Florida panther. This is an animal that got down to 50 individuals in Florida. When you get into something that's small, you run the risk of small things like diseases wiping out this population to extinction. And in this case, they get a neurological disease. And we can actually, if you allow that neurological disease to persist, this panther will go extinct. And you can see that by how the animals are walking, how the panthers are walking, we can actually detect when that disease is in the population and remove those individuals before they can breed. We can also do this with gorillas, and mountain gorillas in particular. We can actually understand their behavior and start monitoring behavior and looking for changes due to stress and things like climate change. And we can now start identifying individuals and describe behavior. So this is in Los Amigos, where Martin is going in a little bit, in a few weeks. This is a jaguar. We can identify that it's a jaguar, we can identify its behavior, and we can identify which jaguar it is. And thanks to nanosatellites, we can have that information in real time. So if we see a poacher, if we see a behavior, or we see a disease, in real time we get that notification and we can intervene, rather than weeks or months later when people go to these camera traps and they collect the data. This is one of the most recent devices we did. These are Persian leopards in Turkmenistan. This is my team, and what I love about this is my team we have field programs, and now those field programs are using this data on the ground. And because of another one of the technologies I'm going to just briefly talk about, we now know one of these leopards has traveled 200 kilometers in a month between reserves, so we understand where to put the corridors to be able to protect them. Our other technology is something called WildMe. It's a lab, and this is cloud-based, and this allows us to count individuals. And it started with whale sharks. And the thing about whale sharks is they show up, and then they're huge, and they're gorgeous, and they're amazing, and then they disappear, and we don't know much. And when WildMe started, there were 300 whale sharks known to science. It was a whale shark biologist, a NASA scientist, a mathematician, and Dell's database engineer that worked together to build this. And what they started doing was actually using citizen scientists to take pictures of the whale sharks. Because of the pattern on the back looks a lot like stars, they used an algorithm from the Hubble spacecraft to actually match that pattern to individual whale sharks. And they went from 300 to 3,000 using citizen scientists. But then they started using AI to actually look at every YouTube video, start scraping it for data, bots to query the posters to get more metadata, and they were able to increase the number of whale sharks to 22,000 and double the amount of whale shark hotspots known in the world for us to protect them. They now do this across countless species. because sometimes it's really hard to count species. If you can tell me how many zebras are in the photo, it's hard to do. But machine vision does a really great job of being able to do this. So we now do this for 217 species. We're following 256,000 marked individuals across those 217 species. We're supporting 2,900 researchers all over the world and processing 1.32 million animal encounters. So one of the most powerful things we could do to tell, are those populations shrinking or growing, which we really need to know, and what is the impact on our biodiversity? And we do it in land, in the oceans, with a variety of different species. This is the last thing. The most recent thing we started to do is counting from above. Because it used to be, if you were going to count something like elephants, right, it was a note taker, two note takers sitting on a plane counting everything that they saw as they're flying over. And you're getting airsick, and the planes are maybe not always that great, and you're a little bit worried about your life. You don't know when the last time they did maintenance. And so one of the things we want to do is automate it. If you guys can actually see the elephants in the picture, I commend you. I have a hard time, but machine vision can actually pick that up. And this is a program called Scout, right? But the other question is, what happens if you have a lot of caribou and all those dots are caribou, right? And again, we can use machine vision to count them and allow us to get that insight and automate those processes. But I think the most exciting thing we're just about to embark on is working with these giants. These are literally the giant sequoias. That's a population of trees. They remind me of the dinosaurs. They're the biggest trees in the world, and we're about to lose them. And so we are doing the first, we're about to lose them because of this little thing called the bark beetle. The bark beetle actually was not an invasive species. It used to be part of the habitat, but because of climate change and fire are changing, we're now at the risk of losing them. So we're doing the first count of every sequoia in the world, which are all in California, and then assessing their health with the National Park Service or National Forest Service, indigenous tribes, and private lands to be able to manage them together. So this is, I think, one example of what exponential technologies can help us do, and why conservation, which was set up as a crisis-based discipline and a solutions-based discipline, allows us to give hope.
Yeah, thank you very much, Alex. I think the interesting... Yeah, I think one very interesting thing which doesn't surprise me as a scientist so much, because I had already a hard time. I was spending time in the Serengeti, for example, and when you see the Great Migration, where 1.2 million animals participate, then you realize that it's difficult to count these animals. But the interesting thing is that it's difficult to count those that have an interesting pattern, like giraffe or zebra, that it's difficult to count the many, like caribou or wildebeest, and it's difficult to count the giants, like the sequoia trees. So, yeah, and I can tell you, it used to be very difficult to get the data, and it was very tiring to look at the camera trap pictures, so thank you very much for making our life easier. So now Alex explained to us how can we help wildlife with technology, and I'm very happy to have Martin here with us, because Martin now is able to explain us how animals help us, because we heard, we are like the wrap-up of the nature track here, of course, and if you attended other panels of the nature track, you are aware, and hopefully you're aware of this anyway, that ecosystem services are assuring our survival on this planet. But mostly we think about how can we help nature. We very little think about how nature can help us, and very few people, unfortunately, decision makers in politics and companies understand how much they depend on the services of nature. So Martin, please share your fantastic research with us.
Well, thanks a lot. It's really nice, because Alex and I know each other since a long time, and it's really nice to link up, because you're doing the populations, we're doing the individuals. And this is now possible because we have IoT on a global scale, in most situations at least, and we do what we call the Internet of Animals, which is linking together sensor information from animals. So it's linking to what Alex is doing, but we're linking the individual animals together as well. And there's so much information in there. I mean, as you know from cell phones, if you link them together, you have a novel property of sensing. it's not foreseen in the individual devices, it's only seen in the linking together. And this is what we're doing. We have 6 billion locations now and growing, global community of people that are contributing to that. And the key is that we have a system.
A system that doesn't work, obviously.
Doesn't advance. Can you advance it from somewhere else?
Well, just look at how nicely the animals are moving, though.
Okay, now it works. We have started to work on a system that really does IoT for biodiversity. We thought we'd do a rapid prototyping on the ISS, worked with the Russians, worked beautiful. Except that when the war on Ukraine started, we stopped our collaboration. So the system still works beautifully if you're out there listening to the ISS every day, coming by a few times. So it's working perfectly, except we stopped it and started a new one. And the CEO of the company who's doing that, Gregor Lange, is here, a Munich startup space company. Because we learned 2 lessons. We have to democratizing the information. We need control over the system from bottom up, not from top down. And what we also learned is it's a perfect system. This is the right kind of waveform for the kind of stuff we're doing. So we're linking to the camera traps, we're linking to animals around the globe. And what we did during the time when it was really running was, trying to understand connections on the planet. And this is our common cuckoo. When you hear a cuckoo in your yard, you know biodiversity is okay because other animals are there. So it's a sentinel for biodiversity. And they go from Kamchatka to Angola, and they meet the Europeans that do the short distance migration going to Angola. But this is only part of, it's just one species of 1,500 that we already have in MoveBank in this global database. Now what we also do is to have small tags on small animals, like this death-head hawk moth, which many of you may know from the movie Silence of the Lambs. They're being tracked now with IoT devices across Europe. But you can also do it with very small devices on large animals. And you need small devices because these rhinos have the most delicate ears. Anything that's beyond 15 grams falls out, moves out. But you can protect them, and that's pretty important. It's actually more important to have the other animals tell us what's happening in the environment, which is really possible, something like Kruger Park. Because when you know that the animal is in trouble, like this rhino, it's too late. The other animals, zebras, wildebeest, lions, they tell you things. They also tell you things when they are in trouble. For example, this pangolin that we are tracking told us, oh, I'm in trouble. So we sent somebody out
in
to
big
check.
trouble, I would say.
Well, they're pretty good. So this one survived. Our tag barely survived, but it did. So it sent us the information. We know everything that this pangolin experienced. And I think that's the kind of information that we now have on a global scale. But we also can learn from that, and that is on our goats at Mount Etna. They're actually transmitting the information in real time. They also give it to me on this little ring. If they get nervous, I get a signal telling me that these animals are experiencing something, probably the next eruption coming. And that's already transferred into the next generation of people that are really learning about that around the world. And I think that's exciting because we have an Internet of Animals. We can tap into the sixth sense of animals. This is nothing magical, metaphysical. It's a physical property of interacting sensors. And that's what we're doing in sort of collaboration between these different partners.
Thank you very much. Yeah, so maybe two stories, one for Alex, or one I found very interesting with the whale shark project that, now I forgot the name of your colleague who's doing it.
Jason.
Jason, yeah. Yes. And Jason, he told me that the AI application actually screens social media for whale shark pictures. And this, I mean, we're all somehow thinking about citizen science, and people divers very often, scuba divers take pictures, selfies with whale sharks, or they take pictures of whale sharks, but they would never send that to a scientific institution. Now, maybe you can explain this a little bit, what the AI does, because I found this really, really interesting.
Yeah, no, so Hubble, it takes a lot of pictures of stars, as you can imagine, and you have to then go through a lot of data to identify where those stars are in the universe. And they said, let's apply that algorithm to the pattern of dots on the back of a whale shark that look like stars.
Sure, but what I think is interesting that the AI even screens the social media,
Yes.
because these divers, they don't send their information to the scientific institutions, but they post it on the social media. And the AI now is not only able to see, oh, this is a whale shark, and identify the whale shark. If it's an unknown whale shark, the AI even gives it a new identification number. And then recently, I think you said the AI starts scientific projects. So, for example, to connect these presence-absence data in a way with other environmental data.
Yeah, one example is just ship strikes. So actually understanding, because these ships all have transmitters on them, we've identified 97 sort of hot spots for potential ship strikes, so we can start diverting ship routes, make them more aware that whale sharks are in the area, and reduce the risk that is available.
And this maybe because we are talking a lot about economics, and this is actually a very interesting economic aspect for people like, I don't know, how do you call them in English, the ship owners, you know, those that shipping companies, because if a whale or a whale shark is hit, that is deadly sometimes for the animal, but it's also bad for the owner of the ship, because the ship gets, somehow damaged. Now, if we can combine these data, we'll reduce the threat to the wildlife, but we also reduce the economic threat to companies. And I think all of us, you're working with moving animals. Now, if you look at protected areas, these protected areas, usually they don't move. And maybe you can tell us a little bit about this, how this could help.
The Canadians have already done that for whale safe on the East Coast. Works beautifully. Whales come with the tags, they tell us they're here. You know, the shipping areas, and then you can protect this. I mean, you can dynamic protection around the planet for animals, and that's, I think, really exciting. And the future will be a lot better because AI will also predict what animals are doing. We just got our colleagues at Columbia University got a 20 million NSF center doing AI on all these data that we have for all these animals, and that will start in a few weeks. Then we have real predictions, like a weather forecast for animals.
And I think the interesting thing is that with these tags becoming so small and much cheaper now, we have an abundance of information. I mean, I just read your book, and there was this incident of this small bird. You were observing actually whale sharks, and the bird was landing on the ocean.
Little ovenbird, which is not supposed to land on the ocean.
Yeah, but it didn't die, did it?
No, it just rested and then flew off again.
Yeah, and then if you remember the pictures or the slide Martin showed us with a common cuckoo. Now, you've seen that they all travel across the Sahara, which I think previously was probably unknown. People usually thought, okay, the animals will somehow avoid the Sahara, they will avoid the open ocean, and
It's also interesting that they give really good weather data. So the German Weather Service is tuning into that. They're including that now. NOAA is already doing that with elephant seals diving and so on. So that's really exciting. But you also mentioned the gorillas, and I wanted to say something about that, because the gorillas are actually out doing their stocks, because they now own money in the interspecies project, interspecies money project. So they have a bank account, and every night they can verify that they're doing fine. The people that care about them, that care about the environment, are being paid out money.
And since gorillas are so smart, they all have their smartphone and they're checking their online bank account.
And I think that's super exciting, because you have these umbrella species, these umbrella animals that are in areas, and they tell you through their ear tags, their collars, whatever, that everything is good, and then people are being rewarded for that. So it's a democratization of the rewards for preserving biodiversity. And I think that's what you do with the camera traps.
It is so important to do that, because I think for too long, conservation, we've asked those who can least afford it, who bear the greatest burden of protection, to pay all the costs, while we in the West or in the North, or however you want to say it, drive the demands on those environmental resources that are causing the problems. So this is a way to reverse it, and I think is brilliant.
Yeah, I think so too, because if we're looking at we have a conservation finance gap of about $800 billion a year. That might sound a lot, but if you think about the global GDP, which is 120-something trillion, we are talking about less than, let's say, 1 0.7% of the global GDP money we would need to achieve the biodiversity goals. Now, obviously, we are unable to get the money. I don't know. Everybody I talk to, all the rich people I talk to tell, and all the CEOs of companies always tell me, well, money is not a problem. But when you ask them, okay, here's my account, please transfer the money, then somehow it becomes a problem. And this, I think, is a very, very interesting approach, because one thing also with nature protection, or a challenge, is that if you give money, you hope that something happens, either because you had you decided on measurable indicators, but very rarely this, what you just said, happens, that people who actually protect animals or ecosystems get paid for this work. And I was working, as I said, many, many years in West Africa. I was also working a little bit in Central Africa, where, for example, indigenous people are paid for killing elephants, and they are paid with a bottle of alcohol. So to kill a forest elephant costs the organizer of this international illegal trade, like maybe $1, and so the guy who kills the elephant gets $1. And this has a huge negative impact of the ecosystem and on the local societies as well. So if we rather would pay $1 a day for protecting the elephant, that would still be very, very cheap. And it would make not only the animals and the people in Africa, it would also make us happy, because I think and that's an issue with citizen science. People like to see the impact, and the real data would now enable people, you give $1 and you see, okay, this made my rhino, my elephant, my whale shark happy for the day. So I don't know, do you have a bank account? Where's the gorilla's bank account?
In real time. I mean, they call in and mention if things are wrong. And they all have an email account now. They have no, honestly, every animal, every whale shark, I mean, we're working with WildMe. We have a unique identifier, a universally unique identifier. So it's a passport across all animals. And they are now owners of their own life history. And actually it goes into the Senckenberg Museum and Smithsonian. So it's the first sort of digital museum of animal lives that's being established now.
Okay, so I think we were the wrap-up of the nature track, and I think we all solved it. So we only need a couple of bucks every day for the animals, and it makes you all happy. You get nice screensavers, I hope, with the data of your own animal. And so thank you very much, Martin. Thank you very much, Alex. I think we're all set now.